Hey guys, welcome back. In the second video in this series, I'm going to focus on examples of when secants or segments of a circle intersect outside of the circle. The first one, did examples of intersecting inside the circle, which is your part times part. This one is going to focus on intersections outside the circle, which is going to be your WeWe type problems and your wet type problems. Okay? Um, so if you watched the first video, you know what those acronyms mean. So this one is, we have our two secant lines with our intersection outside the circle, and it's asking us to solve for x. So it's asking us to solve for this missing segment right here, this missing part. So if you remember from the first video, um, when we briefly discussed and talked about the different types, this is the type 2, where you have your two secants. So this is going to be your type 2, so this is the WeWe problem. If you remember, the W is the whole line, the E is the exterior line. Okay? So we're going to look at, the we part of this one first. So we're going to have the whole line, and in order to get the whole line, we've got to add the exterior part plus the interior part. So we're going to have a 9 plus x, not a 9 times x, that should be a 9 plus x. And that'll be the W part of that line. And we've got to multiply that times the exterior part. So the exterior part is, this part that's outside of our circle. So that would be times 9. And now we're going to multiply that times the other line. So if we look at our other line, we have the whole part of the other line. So we're going to add those two together. So that would be your 8 plus 19. All right, so that's your W. And then the exterior part of that one is going to be the 8. So we're going to multiply that times the 8. So that's your whole times exterior equals whole times exterior. All right. On the left side, because we have the variable, we have the x in there, what we're going to do for that one is distribute that 9. So we're going to multiply your 9 times 9, then your 9 times x. So we'll end up with 81 plus 9x. That doesn't look like a plus very much. Let's try that again. 81 plus 9x equals, so on this side, we can do one of two things. Since we have numbers on the inside, we can go ahead and add those together, then multiply times 8, which is probably the easiest way. So we would have 27 times 8 on the right side. Okay? Now we're going to go ahead and just bring this down over here. 81 plus 9x is equal to, and if we multiply this side, 27 times 8, it gives us a 216. So that's going to equal 216 on the right side. And now it's just your basic two-step algebra equation. So we're going to subtract the 81 from both sides, and we'll end up with 216 minus 81 is 135. Then we're going to divide both sides by 9. And we end up with 135 divided by 9 is equal to 15. So we get x is equal to 15. And that would be our solution here. All right. Sounds good? All right. So let's move on to the next example, the next type. Still this type 2 equation, because we have our two secant lines. Our intersection is outside the circle. So this is still going to be the we type, or type 2. So we're going to kind of do the same thing. We're going to look at this whole line times the exterior. And then we're going to look at this whole line times its exterior, and those two have to equal each other. All right? So how do we get the whole line of this purple line? Well, we've got to add the exterior plus the interior. Okay? So we would have our W for that bottom line is going to be 5x plus 2 plus the 7. All right, so I'm going to do that. So that's my W. Now I've got to multiply that times the E, or the exterior. So that has to be multiplied times the 7. So that's your WE part of that bottom line. Now we're going to equal that to the top line. We're going to do the same thing for the top. So we're going to have the interior part, 3x plus 4, plus the exterior part. So that's our W. That's how we get the length of that whole segment, or that whole secant line. Now we got to multiply that times the exterior part. So that's going to be times your 8, which is the yellow portion of that segment. Okay? Now we're going to combine. What I'm going to do next is combine my like terms inside the parentheses on both sides. So I've got 5x plus 9. So combining your 2 plus 7. Then that's times their 7 on the outside. Same thing over here on the right side of my equation. Bring down my 3x. 4 plus 8 is 12. And then I'm going to multiply that times the 8, the exterior. Now I can go through and distribute on both sides. So I'm going to distribute the 7. 7 times 5x gives me a 35x. Plus 9 times 7 is 63. Equals, do the same thing on the right side. So I'm going to distribute the 8. And that's going to give me a 24x plus 8 times 12 is a 96. Okay? Now it's an algebra equation from this point forward. Getting all your x's together, combining like terms, simplifying, all that. So what we're going to do first is subtract the 24x from both sides. Get that x moved over to the left. So that will give me 11x plus 63 equals 96. Subtract the 63 from both sides. Okay, and that leaves me 11x is equal to 33. Divide both sides by 11 now. And we'll get x is equal to 3. Now if we go back and double check, it does just ask us to solve for x. So at that point, we're done. X is equal to 3. Okay. So I got time to do a couple. Let's see. Yeah, one more example. So this is your type 3 problem. We have one secant line and a tangent line. Okay. So if you remember your type 3, the secant is still the whole times the exterior. The tangent is the tangent times tangent. So that's your wet type problem. Okay? So we're going to kind of start off the same way. We're going to start off with the secant line. So I got to do, remember the W stands for the whole line. So that means I've got to add the exterior part plus the interior part. So that's your W. Then your E for your secant line is 18. So your whole line times your exterior. And that has to equal, well, on the right side, we have the tangent, length of the tangent line times itself. So that's going to be your 24 times 24. Or you can just write it as 24 squared. Okay? Either way would be fine. All right, so now we're going to do like we did before. We're going to distribute my 18 over here. And I'm going to go ahead and square that 24 on the right. So 18 times 18, I can't do that in my head very quickly, so I'm going to do it on the calculator. 18 times 18, I get 324 plus 18x when I distribute the 18 equals 24 squared, or 24 times 24. I get 576 on the right side. Okay? And that's essentially this problem. Now it's two steps to solve, so we're going to subtract the 324 from both sides. And we get 252. And then divide both sides by 18. And get x is equal to 252 divided by 18. And we get x is equal to 14. We go back and check our question. Solve for x. That's what we've done. So at this point, we're done with that. So this segment inside the circle is 14. All right? And that's your three types of segment problems, segment links in or around a circle. All right, well, thanks for watching. I'm going to stop this video here. Again, I hope you enjoyed it. I hope it helps. If you have questions, please, you're welcome to leave comments. You're welcome to ask questions in the bottom. And thanks for watching. I will see you next time.